Okay, salam sejahtera and welcome back. Okay, so today we will discuss the last subtopic 3.9 potentiometer. Okay, so potentiometer. A simple potentiometer may consist of uniform bare wire AB with several ohms of resistor. Okay, so meaning that this wire AB is actually a wire, okay, that attached together with the meter rule. Okay, so meaning that usually for meter rule is 1 meter. Okay, so potentiometer actually is a wire attached with a meter rule. Okay, so the wire is connected in series to the constant direct current. DC is direct current supply. So for example, a cell, okay, a driving cell, accumulator, okay, as shown in below. Okay, so actually this potentiometer is a little bit similar like potential divider, where we also do it in a ratio way. Okay, so for example, let's say epsilon naught, your EMF, the battery that you connect, for example, let's say 10 volt, okay, and the total length, okay, or total length of the potentiometer, okay, let's say we say LAB, okay, LAB, the total length is 100 cm. Okay, so maybe they'll ask you to find what is the value for Vx. What is the value for Vx? If let's say the length A to C is only 50 cm. Okay, when equilibrium achieved. When equilibrium achieved. Okay, when galvanometer show 0. Okay, so meaning that we also need to do it ratio. Okay, so what should you do is we draw a loop. We draw a loop. Okay, I use a different color. Okay, so we have a big loop, okay, a bigger loop, and a small loop, okay, and a small, and another one is a small, okay, meaning that only involve the 50 cm wire. Okay, so what should we do is kita buat secara ratio lah. Okay, so we have loop yang pertama, loop yang besar, and loop yang kecil. So kita buat secara nisbah. Okay, so epsilon naught, okay, over your Vx, okay, is equals to epsilon naught, the total length LAB, and the length for Vx is LAC when equilibrium achieved. So you substitute inside, epsilon naught is 10 volt. So 10 volt is equals to 100 cm. Okay, wire is one of the resistor. Wire is one of the resistor. So if let's say 10 volt is equals to 100 cm, so can you find what is the value for Vx? Okay, when it is when it is 50 cm. Okay, so cm we cancel, meaning that your Vx, you will get 5 volt. Okay, so we will get our Vx equals to 5 volt. Okay, so we'll continue with B. Okay, continue with B. Okay, an accumulator. Okay, epsilon naught is used to maintain a steady current I through the resistor wire AB. Okay, because this is a accumulator. Okay, so it will supply a potential energy throughout the circuit. Okay, thus it produces a potential difference across the wire. Okay, at different point it will have a different potential difference. So the jockey is allowed to slide along the resistor wire AB, and the galvanometer will show the amount of current through it. Okay, so when this is the jockey, okay, when the jockey slide along this wire, this galvanometer, it will show. Okay, it will show what is the value for the current. So we need to find the point where the galvanometer equals to 0. So when galvanometer equals to 0, this is the point where the current for both are the same. Okay, so we'll continue the principle. So the potentiometer is balanced. Balance meaning equilibrium. When the jockey sliding contact is such a position on the wire AB that there's no current through the galvanometer at that moment. Okay, so when it balance, meaning that the potential difference across the bigger loop and the smaller loop are the same. Okay, there's no potential difference between them. So therefore, our current equals to 0 because there's no current flowing through because it's balanced. Okay, so at that time, our galvanometer will show 0. Okay, that's because there's no current flowing through. the potential difference across the Vx is equal to the potential difference across the length AC. Okay, because it is at equilibrium position. We refer back. Okay, so meaning that your Vx at that moment is actually equals to the potential difference across A and C, A to C. Okay, A to C. Okay, so this is what it means when the galvanometer equals to 0, your Vx is equals to the potential difference across VAC. So applying a potential divider, we know that our V is directly proportional to the our resistor. V is directly proportional to our resistor. Okay, so if let's say VAC, okay, if let's say VAC, okay, of course the resistor is also RAC. Okay, if let's say your V is VAB, so your resistor also equals to RAAB. Okay, so this is the relationship, meaning that we can combine the potential divider and potential meter concept combined together. Okay, so we look at the continue with the page 77. Okay, since R equals to rho L over A, okay, R equals to rho L over A. So we can cancel off the resistivity and also the area. Okay, resistivity and area, because we are using the same material, because resistivity depends on the material. Okay, and we can cancel off the area because we are using the same area. So therefore, we know that our R also directly proportional to the length. Okay, R also directly proportional to the length. Okay, meaning that the wire is one of the resistor. Okay, one of the resistor. If the wire longer, okay, so resistor will be higher. Okay, kalau panjang wire itu tinggi, panjang, maksudnya resistor itu juga akan tinggi, because R is directly proportional to the length. Okay, so therefore, we can change just now our from the potential divider, our V directly proportional to R, we can change it become V directly proportional to L. Okay, so this is the so this is the equation. Hence, the current in the circuit and the temperature of the wire AB are constant. So V is also directly proportional to the length. So as a conclusion, if you combine the potential divider and the potentiometer, meaning the L by V directly proportional to the resistor, directly proportional to the length. Okay, so we can take V directly proportional to R, V directly proportional to L, or R directly proportional to the length. Okay, so we take this relationship, okay, and all is directly proportional. Okay, so in other words, the potential difference across any 2 points on the potentiometer is directly proportional to the distance between the 2 points. Okay, so we say V is directly proportional to the length. Okay, so the application, we continue. Okay, what's the application of the potentiometer? So potentiometer, usually we use it to compare the EMF for 2 cell. Okay, and we can use it to measure the unknown of the EMF of a cell. And we also can use it to measure the internal resistor of the cell. And this one is the experiment 3. Okay, so these are the function or application for the potentiometer. We use it to compare, to find out the unknown and to find out the internal resistor of the cell. Okay. Okay, so this is the comparison. Just now the application. So one of the application of the EMF is the comparison of EMF. Okay, so here we have 2 cell here, E1 and also E2. Okay, we have epsilon 1 and epsilon 2. So the question say, the method, if initially S is connected to point X, point X meaning that because your book doesn't draw, so we can draw it here. If initially it connect with this one, X, okay, and then at the bottom is Y. Okay, initially when it connect with X, your epsilon 1 is connected, only epsilon 1 is connected to the potential because it's not connected with Y. So the jockey is allowed to slide along the resistor wire AB until the balance point C, okay, where the galvanometer indicates the 0 deflection is located. Okay, so meaning that when you measure epsilon 1, okay, the length is LAC. Okay, so this is the value that we get. Okay, So if let's say switch is then allowed to make a contact with point Y. Okay, now we connect with point Y. Okay, point Y. So point Y meaning that you now connect with epsilon R. Okay, you connect with epsilon R. Okay, you connect with epsilon R. Okay, so now if you connect with epsilon R, so now you connect with epsilon 2. Just now, the first one is you connect with epsilon 1. Okay, when you connect with X, you connect with epsilon 1. Okay, so this is the first one. Okay, so now the second one is now you connect your switch, you turn to epsilon 2. So we find out that if you connect with epsilon 2, okay, you connect with the contact with Y and only epsilon 2 is connected. So at that time, it is a new point. It will located at point D. Okay, so we label it as LAD. Okay, so we can find out what is the, okay, so meaning that if let's say this is epsilon 2, the length is AD. Okay, the length is AD. Okay, meaning that at AD, your epsilon 2 only will balance. Okay, so we can actually determine, we can do it in a ratio. Okay, we can do it in ratio. If let's say epsilon 1, we know that epsilon 1 is 5 volt. And LAC, for example, let's say 10 cm. Okay, 10 cm. So can you find epsilon 2 if let's say A to D is let's say 15 cm. Okay, so can you find the epsilon 2? Okay, so we substitute inside. Epsilon 1 is 5 volt. Epsilon 2 we don't know. EMF 2 we don't know. Okay, LAC, okay, when you connect with 5 volt, total length is 10 cm. Okay, when you connect with epsilon 2, the balance point is at 15 cm. Okay, so find out what is the value for EMF2. Okay, so take out your calculator and calculate what is the value for epsilon 2. So meaning that we can compare the EMF, the value of the EMF. Okay, so 5 times 15 over 10. So you will get 7 point epsilon 2. 5 times 15 over 10. So you will get 7.5. Okay, 7.5 volt. Okay, 7.5 volt. So this is how you can find out the EMF. Okay. Okay, you may pause the video if let's say you want to do calculation. Okay, next we continue. Okay, the potentiometer is balanced when there is no current flowing through. Okay, when there's no current flowing through, we say it is at balance point. Okay, where your G, I are the I that flowing through the galvanometer is equals to 0. Okay, when the jockey is balanced at point C, epsilon 1 is equals to VAC. And the jockey is at the balance point D, where your EMF or your epsilon 2 is equals to VAD. So since V is directly proportional to L, so we can say that our V is directly proportional to L. Okay, or we can write it in this way. Okay, we can write in this way. Okay, it's directly proportional to L and also it's directly proportional to the resistor. Okay, like I mentioned just now, you can either V proportional with L, V directly proportional to R, or V or the length directly proportional to the R. Okay, so either one. Okay, so next, the next function is the potentiometer is to measure an unknown EMF of a cell. Okay, so if let's say using the same circuit as above, the value of unknown EMF 1 ataupun epsilon 1 can be determined if the epsilon 2 is replaced with the standard cell. Okay, so this is the measurement like just now I measure just now the measurement that I teach you how to measure. Okay, if let's say epsilon 1 is given and then they ask you to find epsilon 2, so you can do it using the equations. Okay, the equations between epsilon or the potential difference versus the length. Okay, it's directly proportional. So kita boleh guna cara ini untuk carilah EMF untuk sel yang kedua ataupun epsilon 2. Okay, so we try one question. Okay, example 15. A potentiometer consists of a uniform, wire. So the length is 100 cm because it's a meter rules. And the resistor of 5 ohm. So 100 cm here is equals to 5 ohm. Okay, connected in a series with 2 ohm, a resistor and a driver cell of 3 volt. And inside the driver cell also there's an internal resistor of 2 ohm. Okay, so there's a 2 ohm internal resistor and this is a driver cell 3 volt and external resistor is 2 ohm. Okay, and the total length of x to y is 100 cm. Okay, so meaning that we want to find what is the epsilon 1. We want to find epsilon 1. So meaning that we have two loop. Okay, the bigger one and the smaller one. Okay, so this is a smaller one. Okay, so we do it ratio. Kita buat secara ratio. Okay, so our relationship is our V is directly proportional to length is directly proportional to R. Okay, so since here we have a resistor 2 ohm, 2 ohm, and we know that X to L 100 cm ini actually is equals to 5 ohm. Okay, so we know that the resistor along X dengan Y wire ini dia adalah 5 ohm. So of course we take V is directly proportional to the resistor. Kita ambil relationship ini. Okay, we cannot use length because we besides the length we still have 2 resistor 2 ohm ini. So we cannot use directly proportional. Okay, we must calculate everything in the bigger loop. So kita ambil V versus R. So V total over V1 equals to R total over R1. Okay, so V total here, this is the bigger loop. Loop yang besar is 3. Okay, and R total semua 2 ohm, 2 ohm, and also 5 ohm. So we add together because it's connected in series. So 2 plus 2 plus 5. Okay, because the wire 100 cm is actually equals to 5 ohm. Okay, over V1. V1 actually is your epsilon 1. This is the value that we don't know. Okay, and R1, we don't have the resistor, but we have 75. Okay, so if 5 ohm equals to 100 cm, okay, so 75 cm equals to how many resistor? Okay, how many ohm? Okay, so kita juga boleh buat secara perhubungan R versus L. Kita ambil perhubungan ini. Okay, okay, so R total over R1 equals to total length over L1. Okay, so R total is 5 ohm for this wire. Total panjang ini 5 ohm. Dan 5 ohm is equals to 100 cm. Okay, so we want to find, if let's say 75 cm. Okay, what is the resistor for 75 cm? Okay, so we can calculate. Okay, please press the calculator. Okay, find out what is the value for R1. Okay, when it is 75 cm. 100 cm is 5 ohm. So 75 cm, okay, you will get, what's the value? Yes, 3.75 ohm. Okay, so we notice that for this small loop, loop yang kedua ini, small loop ini, pink color punya, okay, our resistor, because it's X to J, 75 cm, and 75 cm actually equals to 3.775 ohm. Okay, so all this we calculate this one in ohm. Okay, of course, this is all in volt. So later your answer, EMF 1. Okay, press the calculator. Press the calculator. Okay, 3 times 3.75 over 9. Okay, so press the calculator, you will get answer is 1.25 volt. 1.25 volt. Okay, 1.25 volt. Okay, so this is example 15. Example 15. Okay, next we goes to example 16. Okay, example 16. Okay, we have initially, okay, we read together first. In a circuit show, the EMF of the driver cell is 2 volt, okay? And its internal resistor is negligible, meaning that there's no internal resistor. Okay, the length of the slide wire AB is 100 cm. Okay, when the switch is open, meaning that we don't have the internal resistor for ohm because the switch is open. The balance length A to J is 75 cm. Okay, meaning that this is our EMF before the current flowing through. Okay, before the current flowing through. This one we still open. Okay, meaning that there's no current flowing through this loop. Loop yang ketiga ini tak ada current. Okay, there's no current. So what that we measure just now is actually our EMF. After that, when it close, our length now become only 65. Why? Why 65? Because there is an internal resistor inside our epsilon 2. Okay, so first, kita cari dulu. Find the EMF of the cell epsilon 2. Okay, so we take loop pertama, loop kedua dulu. Okay, so meaning that in this loop, we only have this diagram. Okay, because switch S is open. Okay, meaning that the circuit at the last row actually is we can ignore because the switch is open. There's no current flowing through. Okay, so this one is 2 volt and this is the epsilon 2 that we want to find. Okay, epsilon 1 is 2 volt. Okay, so what should we do is we compare. Okay, so again, like what I mentioned just now, we have 2 loop. Loop yang pertama. Okay, and also another loop. Okay, another loop is at the bottom here. Okay, it's a green color. So we compare. Okay, we compare. Loop yang besar, E1. Okay, E1 panjang, the length. Okay, because as I mentioned, EMF or V is directly proportional to length, is directly proportional to the resistor. So since we have the wire, the length of the wire, so we take the relationship between EMF versus is directly proportional to length because we don't have resistor. Okay, so we take epsilon 1, L1, epsilon 2, L2. So L2 here is actually LAJ. Just now L1 is LAB. Okay, so we substitute the value. Epsilon 1 just now is 2 volt. Epsilon 2 we don't know. Okay, length for the bigger loop total is 100 cm. Okay, it's 100 cm. And E epsilon 2, when the switch S is open, meaning that this circuit, okay, we find out that this one is actually only 75 cm. Just now, okay, the upper lobe is 100 cm. Okay, so we substitute 75. Okay, so you can find your epsilon 2. Okay, press the calculator. 2 times 75 over 100. So you will get your epsilon 2 actual value is 1.5 volt. Okay, 1.5 volt. Okay. Okay, next. determine the internal resistor. Okay, internal resistor of the cell epsilon 2. Okay, and to determine the internal resistor, switch S must close. Okay, so when you close, the length only left 65 cm. Okay, so I draw. So meaning that now we have 3 loop because you must close S, the switch must close. Okay, now your switch is closed, so you have another resistor, 4 ohm. And this is the switch. Okay, so you connect back. So this is the switch. Okay, so this is epsilon 2 and epsilon 1 is equals to 2 volt. Okay, so if you connect with switch S is closed, meaning that this one is still 100 cm. But now your AJ only left 65. Kenapa dia kurang? Because now if you connect S is closed, meaning that there is a current flowing through the inside the cell. Okay, so kita ada macam ada 3 lah. Loop yang pertama kuning, okay, and then loop yang kedua, let's say biru, okay, and then we also have loop yang ketiga. Okay, meaning that there's a current flowing through the resistor 4 ohm. Okay, there's a current flowing through the resistor 4 ohm. So here, of course, we have internal resistor. Okay, why just now we don't have? Because there's no current flowing through, because the circuit is not complete. Okay, now if let's say you connect, the switch S is closed, meaning that there is an internal resistor inside the cells epsilon 2. Okay, so what should we do is we compare 1 and 2 first. Okay, so 1 and 2, because it's only involve length, so kita ambil equation EMF is directly proportional to the length. So EMF 1 over EMF 2, okay, equals to 100 over 65. Your EMF 1 is actually 2 volt lah. Okay, so your epsilon 2 or the cell, now you can only measure, you only left 2 times 65 over 100. So you get 1.3 volt only. Okay, 1.3 volt only. Just now you get 1.5. Okay, and now become 1.3. Why? 1.5, why become 1.3? 2 volt, 0.2 disappear. Okay, why disappear? 0.2 disappear because 0.2 is actually internal resistor. There's an internal resistor. So when the current, when the circuit is complete, the current will flow through the internal resistor. Okay, so just now 1.5, our EMF E1 is actually equals to, our EMF E2 is actually equals to V internal plus V external. Okay, so just now is 1.5. When the switch S is open, only there's no current flowing through the internal. So 1.5 is the EMF, the total. But after we connect with the switch S is closed, we connect there's a current flowing through the internal resistor. What we measure only 1.3. That one is actually external potential difference that we can measure. Okay, so meaning that V internal or the potential internal resistor inside is equals to 0.2 volt. Okay, 0.2 volt is disappear because of there is an internal resistor. But the question said they want to measure the internal resistor, not the internal voltage. Okay, not the potential difference. So we need to find V internal, okay, is equals to I R internal. Okay, so 0.2 I we don't know, but we can find because we know that V external, okay, our V external is equals to I R external. Okay, R also R external. So V external is 1.3. Okay, just now what we measure. Okay. And then I, we don't know. R external is equal to 4 ohm. So we find out that actually the current I, okay, press the calculator. I is equal to, what's the value? Yes, 0.325. So we substitute inside here because it's connected in series. So of course the current also will be the same because it's in series. Okay, times the internal resistor. So our internal resistor, we will get it is equals to 0.615 ohm. Okay, so this is the value, or this is the way how you can measure the internal resistor. Okay, so thank you class for watching. Okay, so we will continue with the next the new topic. Okay, magnetic field for chapter 4. Okay, so that's all for chapter 3. Thank you class. See you again. Bye bye.